to. So this one, can you sum up this one now about alpha, beta, and gamma, how they are behaving in
Yes, sir.
electric field?
Since alpha has a positive charge and is heavier, it goes towards the negative negative side, with a low gradient curve. Then beta has negative charge, so it repels from the negative side to the positive side with more curve because it is less heavier, and since gamma ray doesn't have any charge, it just goes undeflected.
Okay, so all these things, whatever you summarized, it's written here also. Huh? It's written here also about alpha, beta, and gamma. Can you read from here? Because we are doing it because we have the recording, and that's why students will be benefited who are absent. So,
Deflection of radioactive particles. The behavior of the three types of emission in an electric field. The alpha particles behave like positively charged particles and they are deflected towards the negative plate in a parabolic path. The beta particles behave like negatively charged particles and are deflected towards positively charged plate. Beta particles show much greater deflections than alpha particles because of their lower mass. The gamma rays show no deflection in the electric field and travel in a straight line as they have no charge.
okay, thank you so much. Now we are going to this one. Deflection of radioactive particles in a magnetic field. So can Moshe, Moshe, hello
Yes,
Moshe,
sir, I am here. Yes, sir.
still you are not ready to read?
No, sir, আমরা পড়তে দিলাম আমি ঘুমাই যাবো স্যার অলরেডি অবস্থা কাহিল
Okay, okay. Now can you read Ziba from here?
Yes, sir. Deflection of radioactive particles in a magnetic field. The alpha particles and beta particles are deflected in directions given by Fleming's left-hand rule. Alpha particles are positively charged. The direction of movement of alpha particles can be considered as in the direction of conventional current flow, i.e. left to right. Therefore, the force on them must be towards the bottom. Beta particles are negatively charged. The conventional current flow is in the opposite direction of the movement of beta particles, i.e. right to left. Therefore, the force on them must be towards the top. Gamma rays are not affected by the magnetic field and they travel in a straight line.
Okay, so this one, the dotted points. You see the dots here given. It's written here. B field out of page. B field out of page. Okay, so B
Sure.
field means magnetic field. Hello, Adnan. Adnan,
Yes, sir.
thank you for joining. So B field means magnetic field out of page. That means this one, the first finger is coming outwards. That way, you fix your thumb, first finger, and second finger in a way that this way, the way is shown in the diagram. This is Fleming's left-hand rule. You should fix it the same way is shown here. The left hand and the thumb is making 90-degree with magnetic field. Then magnetic field also making the first finger magnetic field. and the current also making perpendicular or 90 degree with the second finger. Okay, first finger, second finger, and the thumb, they all are in 90 degrees. Okay, this way you should fix, and your magnetic field or the first finger is will be upwards. This way you fix. Then we have here alpha. Alpha means positive, right? You know about the current. Current is always going from positive to negative according to conventional current flow. Can you remember that one? In our circuit diagram, uh, we got in which topic? Can you remember the topic name? It's in current electricity. Okay, this way, if it is the circuit, it is positive and it is negative, then it's our conventional current flow I. That means it goes from positive to negative. So alpha source, these are positive. They are going from left side to right side. That means it's following the conventional current flow. So your second finger is conventional current flow. It's showing the direction. You fix the alpha with the same direction, and your uh, first finger will be the magnetic field going upwards. Then you will see your thumb is showing direction to downwards. Uh, do you understand it? Are you checking it with your hand also, students? Hello, hello. Do you understand it?
Yes, sir.
Okay, so you are getting the alpha particles direction downwards for that reason, as your thumb is showing the downward direction. That's the direction of the force or motion. Okay. Now about the beta particles. Beta particles is opposite charge of alpha particles. So its direction is, you know, showing reverse this way. So if you think of the beta particles or the electrons are moving in this direction, that means current is going to this direction, right? In our Fleming's left hand rule, we don't have any direction for beta particles. We have only for current. That's why we should consider the current direction here. Okay, as beta particles is moving in this direction, we should consider the current direction in opposite. That is conventional current. So here we are getting the current direction. This way we should reverse it. The way it was going previously you are doing, now it will do previous. Your magnetic field is still upwards, but you just turn your uh, which finger? Second finger, right? Turn your second finger in opposite direction the way you did before. Are you done with this? Hello? Ziba, Adnan, Moshe?
Yes, sir.
Yes, sir.
So now you check that your thumb is showing opposite direction than before. That is upwards. Now it's showing it upwards. Is it clear to you? Is it clear? Is it coming upwards? The thumb.
Yes, sir.
The thumb. If the thumb is coming upward, that means that's your beta direction motion or beta directions deflection. So in magnetic field, how the alpha and beta is deflecting, we are showing that one. Also, we are bringing that idea, the idea we got before, that alpha particles are deflecting less because they are heavier, and beta particles, they are lighter, that's why they are deflecting more. Again, the beta particles which are slower or lower kinetic energy, they are deflecting most, and they which are faster with higher energy, they are deflecting least, right? Is it clear about alpha and beta?
The beta is
Yes,
basically the opposite of alpha.
Yes, yes. Opposite of alpha, and also we should maintain that one.
The curve.
The curve is more for beta. Okay, that one also is carrying marks. Sometimes the structured questions, they are asking you to draw. That time we should maintain it. Okay, if you only show the deflection correctly, you will get 1 mark, and if you maintain this one, that one is more curve, another one is less curve, then you will get 2 marks. Okay, this way the mark scheme is generated. And the third one, gamma source, like before, as it is uncharged, that's why it will go undeflected. Here also in magnetic field. So is it clear, all of you?
yes,
Yeah, Adnan, is it clear? Hello,
Yes,
Adnan,
sir.
Ziba.
Yes, sir.
We can go to next part, right? Now,
Yes, sir.
okay, we are going there. Nuclear reactions. Now we have idea of chemical reactions. In chemical reactions, what happens from the outermost shell? There is transfer of electrons, but the element remains same. As there is no change in atomic number, since the atomic number uh, atomic number is the main cause for changing the elements. Like if you think of carbon, carbon has 6 protons, that's why it's carbon. Then oxygen, it has 8 protons, that's why it's oxygen. Hydrogen, it has only 1 proton, that's why it's hydrogen. So if we somehow change the number of protons inside the nucleus of hydrogen, then it's no more hydrogen, it becomes then helium. Got this point? Hello, hello.
जी sir.
Yes,
You
sir.
understood it, how the elements are changed. It's changing due to the number of protons. If you are changing the number of protons, then the element will change. Until and unless you are changing the number of protons, it will remain the same element. Whatever, how many electrons are taking from there, maybe you are taking all the electrons, but the protons all are available there, still is the same element. Okay, is it clear? So the first thing is here, the difference is chemical reactions deals with electrons, and nuclear reactions with the nucleus or nucleons. Nucleons means protons and neutrons. Is it clear, all of you? Hmm? Hello, what is the difference between chemical and nuclear reactions? Can anybody tell me? Then I can get confidence that you understood.
Sir, take us.
Hello, hello, tell me about the difference between chemical reactions and nuclear reactions.
The chemical reactions are the transfer of electrons, and the nuclear reaction happens when there is a change in the mass of nucleus.
The mass of the nucleus, or you can say transfer of nucleons. Okay, nucleons means they who are staying in nucleus, who build their house in nucleus, they are called nucleons. Okay, Now, this part from here, uh, nuclear reactions. Can Adnan read from here? Nuclear reactions occur. Adnan, can you read from here?
Oh, yes, sir.
From here, nuclear reactions occur both
Nuclear
in.
reactions.
Hmm.
Chemical reactions results only in the transfer of electrons. Element remains the same. But in nuclear reactions, the nucleus in a reacting element and the produced element are not same. A nuclear reaction is a reaction that changes the mass of the nucleus. Nuclear reactions occur both in nature and in nuclear reactors. In nuclear reactors, the standard nuclear reaction is the decay of uranium-235. The super heavy elements in the periodic table, that is to say, those with atomic numbers exceeding 83, undergo alpha decay to reduce the number of protons and neutrons in the nucleus of the atom. An example of alpha decay would be the decay of uranium-235 into thorium-231. একটা equation দেওয়া আছে ধরে এখানে।
Yeah, you read it.
Elements with a
Read it.
high
Hey,
neutron
listen. You can read also the equation. I am teaching you now. I am saying you now, and then next one you can continue. Right? This one is uranium 9235. Okay. Uranium. You repeat with me. Uranium 92-235.
in 92 to 35.
Yeah. 92 means its proton number is 92, and 235 means its mass number is 235. What does mass number mean?
Number of protons and neutrons in an atom.
Yeah, proton and neutron, sum of that is our mass number or nuclear number. So if you subtract 92 from 235, then you will get neutron numbers. Okay, number of neutrons available in this uranium isotope. So here we got uranium, and if one alpha particle is losing from this or emitting from this uranium, decaying from the uranium, that time you are losing 2 protons and 2 neutrons, right? You know about alpha particle. Can you remember? Alpha particle has 2 protons and 2 neutrons, right? Can you remember that one? So
Yes,
alpha
sir.
particle, it has 2 protons. That is atomic number is we cannot say here atomic number because it does not have any electrons. We have here its proton number 2 and its mass number 4. Okay, so it's losing 4 from here and losing 2 from here and turning to thorium, another element, right?
Alpha is helium, right?
Alpha is one particle, huh? Hello, what you asked, Ziba?
Like alpha, it has the heliums, everything.
Yeah, helium's nucleus. Nucleus is like helium, but we cannot say it helium because it does not have any electrons. Okay, only the nucleus is nucleus of helium, similar to this alpha particle. Okay, that one. So we say alpha is like helium nucleus. Now we have another element, that is thorium. Thorium 90-231. Already you understood how this 231 comes and how this 90 comes, right? Adnan?
Yes, sir.
So now you read the equation.
Urine 23592 to alpha 42 plus 231 thorium with a proton number of 90.
Very good.
Elements with a high neutron to proton ratio undergo beta decay, in which a neutron is changed into a proton and an electron. As the entire process takes place in the nucleus of the atom, and the nucleus can only contain protons and neutrons, the electron that is generated is ejected from the nucleus as a beta particle.
Okay, so here we got uranium 235, and here the atomic number is 92. So can you tell me what is the number of neutrons here? Number of neutrons, 235
Of what?
minus,
Urine.
yeah,
235 minus 92.
92. So uh, what is the number? Can you tell me? If you subtract what it comes,
143.
143, sir.
very good. So this is number of neutrons.
মুসিনা বললি ঘুমায় যাবি?
ঘুমাইলে কি আর ক্লাস করতাম নাকি বলদা?
Okay, look.
একবার ঘুমায় গেছিলাম, আবার জায়গা উঠলাম
You,
মাত্র।
what they said, look here.
আমার
High,
মাইকে তখন অন ছিল।
look, high neutron to proton ratio. So number of proton is 92, number of neutron is 143, right? So there is high proton neutron ratio, and because of this it's going to beta decay. There will be beta decay. So in our previous discussions we got this one, that if the number of neutrons are more, the neutron will break down and it will produce one proton and one, but if neutron breaks down, then what produce, what created? You tell me, anyone? If
স্যার আরেকবার একটু কোশ্চেনটা বলেন, বুঝেন না।
আরটা একটু বলেন তো স্যার কোশ্চেনটা। এই
yes,
মুছিতে আমার কথা কপি মানুষ
the
কেন?
question is,
তুমি আমার পরে বলছো।
the
পরে
question
বলছি
is,
মানে আমি মাইক অন করতে দেরি করছি।
listen,
একটা থাপড় দিব না, চুপ।
Proton.
listen. Neutron number is more, right? 143. So it will try to balance this number until it reaches to this number. It will go for beta decay, right? Now when this neutron wants to convert to proton, the reaction occurs this way. It produces one proton and one electron. Okay, and here we are getting electron. That's why it is called beta decay. Is it clear to you now? Hello.
Yes, sir.
And if we have like another neutron breaks down, there are lots of neutron, right? Extra. Then you are getting more. Here another proton plus electron. So these two protons and with other two neutrons is creating alpha decay. Is it clear how this alpha decay is coming?
Yes, sir.
Is it clear, all of you? Like here we are getting two protons, we have more neutrons, right? Mashallah, here we have lots of extra neutrons. So from here we can get more two neutrons. Those two neutrons and these two protons can combine together to create alpha decay. And here we are getting already beta decay. So in this uranium we are getting alpha and beta decay. Is it clear? Hello.
Yes, sir. Yes,
Okay.
sir.
Not only this, beside this emission, we are also when you will go to A levels, A2, that time there is also one part of nuclear physics. We are discussing like how uh, the binding energy, the protons, neutrons, they have binding energy. Okay, and Einstein's one equations, E equals mc square, right? Do you know this equation, E equals
স্যার
mc
এই
square?
ইকুয়েশন রবীন্দ্রনাথ ঠাকুর বানাইছিল।
Yeah, then Einstein stole it, right, from him.
হইতে পারে স্যার।
Yeah,
হাই প্রবাবিলিটি
and
স্যার।
before that Adnan made it, right?
টাইম
এই
ট্রাভেল।
জন্য এই জন্যই
And
স্যার সব ভুলে যেতেছি আসলে, মানে বাংলা একদম নষ্ট করে দিছে স্যার।
okay, now look here, the mass, there you will find one thing, that is mass defect or mass difference in the binding energy of protons and neutrons. This mass, what is the difference in mass, that is converting to energy, and it's going with the speed of light. That energy we are getting in the gamma radiation. That one is kinetic energy. Okay, in gamma radiation we are getting that one. So in one nuclear reactions also we can get gamma radiations beside alpha beta. Is it clear now how we are getting alpha beta and gamma, Ziva?
Yes, sir.
Yeah, so I tried to give you a little bit idea about the gamma radiation, how it comes, though it's not in your syllabus that how gamma radiation is coming or is produced. Only you know the properties of gamma radiation, how it is deflected, and how it is ionizing. That's it. Okay, so till now you understood, right?
Yes স্যার, বাই বাই স্যার, আল্লাহ
Till
হাফেজ।
now you understood. So our class time is over. Our class time is over,
Yes, yes, yes.
or it is
More or
still
less.
ইয়েস
10:25.
ইয়েস স্যার।
আরে না 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 না, শেষ টাইমিং স্যার, আপনার ল্যাপটপে সমস্যা আছে
Is it 10:25?
হইতে পারে
স্যার। ইট ইজ
স্যার। 10:20 না,
10:26।
10:20 না।
Hey, Ziba, is it our class will be continued till 10:25, right?
Yes.
So we have
হ্যাঁ স্যার,
8 minutes left.
10:25 পর্যন্ত বেজেই তো গেছে।
No, it's 8 minutes left. Wait for a while.
আরে আপনার ল্যাপটপে সমস্যা আছে হয়তো, আপনার হয়তো
Wait for
বাসায়
a
ওই যে
while.
স্যাটেলাইটের মধ্যে মধ্যে হয় যে বাসা
Okay,
সবগুলা
okay.
ডিভাইসে টাইম চেঞ্জ হয়ে যায়।
Listen. We are not going for new things. Just recap this part. Recap this part, then we will close. No problem. Can you sum up how much it is possible for you, Adnan, on this, the whole thing we discussed now, nuclear reactions?
ও আমি সাম আপ করব?
Yeah, please. Then
আমি তো কিছু লিখি নাই, আমার তো নোট পরে
no,
তুলবো সামারাইজ করে।
it's written here. It's written here
হ্যাঁ,
already.
তাহলে একটু উপরে যাইতে হবে।
Everything is
ফার্স্ট
written
অফ অল
here.
কি যেন করছিলাম, ওই
No,
যে
here it's written.
পেনেট্রেশন, তারপর
No.
এইটা, এই যে নিউক্লিয়ার রিঅ্যাকশনটা।
Only nuclear reactions. Only this part.
ও
Other things we
আচ্ছা আচ্ছা
already
আচ্ছা
summed
আচ্ছা
up.
আচ্ছা আচ্ছা, হ্যাঁ এখানে হচ্ছে কেমিক্যাল রিঅ্যাকশন আর নিউক্লিয়ার রিঅ্যাকশন এক্সপ্লেইন করা হয়েছে। কেমিক্যাল রিঅ্যাকশন হচ্ছে শুধু যখন ইলেকট্রন ট্রান্সফার হয় তখনই হয়, আর নিউক্লিয়ার রিঅ্যাকশন হচ্ছে যখন ওই যে নিউক্লিয়াসের মাস চেঞ্জ হয়ে যায়। এই
Excellent.
নিউক্লিয়ার রিঅ্যাকশন হচ্ছে নেচারেও হয় আর নিউক্লিয়ার রিঅ্যাক্টরেও রিঅ্যাক্ট হয়। আর যেরকম আমরা একটা ইকুয়েশনের ফর্ম, কিছু কিছু পিরিয়ডিক টেবলে অনেক সুপার হেভি এলিমেন্টস আছে যেটার অ্যাটমিক নাম্বার একদম 83 পার করে ফেলে। তারপর ওগুলা হচ্ছে একটা এক্সাম্পল, ওই সময় হচ্ছে আলফা দিকে হইতে পারে, যেরকম ইউরেনিয়াম 235 অথবা ইনটু থোরিয়াম 231। তারপর যেগুলা এলিমেন্টে হাই নিউট্রন টু প্রোটন রেশিও থাকে ওগুলা বেটা দিকে আন্ডারগো করে, আর যেখানে হচ্ছে মানে একটা নিউট্রন হচ্ছে একটা প্রোটন আর ইলেকট্রনে চেঞ্জ হয়ে যায়। আর এই পুরো প্রসেসটাই হচ্ছে একটা নিউক্লিয়াস অ্যাটমের নিউক্লিয়াসে হয়। দ্যাটস ইট।
Yeah. So thank you so much. You discussed a lot. Now I want a little bit more from Ziva. Can you tell me how alpha and gamma radiations are coming?
And gamma radiations.
Yeah, yeah.
Don't know how to say it though.
Yeah, first you tell me about alpha, then you say gamma.
এই গুগল ট্রান্সলেটর ইউজ কর, ভালো আছে?
Here is a basic. Here is a basic. You see how the alpha is coming, right? Yeah.
Alpha comes from when the neutron has a proton and electron, and when they undergo change
Mhm.
from electron, when electron is subtracted from the proton.
Look, alpha is coming. You have here 2 protons, right? Already,
Yes, sir.
and you have some more neutrons here, right?
Yes.
This is 143. So you can get here 2 neutrons, and these 2 protons, they are combined together, right, to get alpha. Right, this way, until you are getting this one balanced, you will get more alphas, right? You will have more beta decay, and you will have more alphas. And how we will get the gamma radiation? What I told about gamma radiation?
When the electrons goes, when the
Yeah,
electrons are changed,
not
the
electrons.
equilibrium is where
Not
the
electrons. There is mass defect. There is binding energy between protons and the neutrons in the nucleus, right? And when they are converting from uranium to thorium, that time there is the difference between the binding energy. Okay, that difference is uh, getting as M, this one, mass defect. Okay, so this mass is converted to energy when they have speed of light. That is gamma radiation. Okay.
yes, sir.
Okay, that's all right for today.
আসি স্যার, আসসালামু আলাইকুম।
Thank you so
Thank
much.
you.
Thank you so much.
আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহ। আল্লাহ হাফেজ স্যার।
Walaikum
বাই বাই।
salam wa rahmatullahi wa barakatuh.
Thank you for the class.